What's up, my little tortilla chips? Today, we're going to talk about a review of Unit 6. Unit 6 is all about matrices. So we're going to look at stuff like, ooh, not like that. Like this. Like this. And we're going to do a whole bunch of stuff with matrices. There's kind of a lot to go over, so buckle up, put your big kid chonies on, make sure you got a clean pair of socks, and grab a pencil. All right, let's go look. So what we're going to start with is multiplying matrices. And you're going to look at this scenario and go, Mr. Barton, you're insane. This is too much. Already, this is too much, and it's the first slide. Breathe. You'll be fine. You've already done this. It's review. So when we are multiplying matrices, I've got two example matrices here, A and B, and we're going to do A times B. The first thing we need to check are the dimensions of A and B. Your dimensions are going to be the number of columns, so 3, by the number of rows, 2. Number of columns, 2, by the number of rows, 3. You are allowed to multiply these matrices together so long as these inner numbers match. And then your answer, A times B, is going to have dimensions of the outer numbers. So this could be a 3 by 3. Okay. So once you've checked to see, am I even allowed to multiply these two matrices together? Now you have to do the multiplication. So let me show you how that works. The order of the multiplication matters, which is different from standard multiplication of numbers and variables and stuff. So what we want to do is look at the order, A, then B. And what we're going to do is we're going to take the rows of the first one and multiply them to the columns of the second one and add the terms individually. So we're going to take the first row of A and multiply it to the first column of B. Those are going to give us the first element of our new matrix. So when we multiply the first element of the first row times the first element of the first column. So A times A is AA. Plus the second element times the second element, B times D. Then to get the next term, all we do is move over to the next column, and we do A times B plus B times E. Then to get the third element, we go to the third column. So notice this whole time I'm in the first column of the new matrix. So we're using the first row of this one the entire time. And sorry, did I say column here? We're in the first row, so we should stay with the first row the whole time. Once we want to get the second row, then we go down to the second row, and then we go through each of the columns individually again. And then you get this matrix. This one looks really complex because it's got all the variables in, but once we actually do it with some numbers, it'll simplify and it'll look a lot nicer. All right. So that's the process we're going to do. We're going to do row times column, 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 element, element, element. Next row, column, 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 element, 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 and so on until we're finished. All right. So let's look at these two examples. We have a matrix A, which is this thing right here, a matrix B, this thing right here. They want us to find A times B, and then they want us to find B times A. Let's do A times B first. A times B. Let's check our dimensions first. This is a 3 by 2 matrix, and this is a 2 by 2 matrix, or a square matrix. So because these inner numbers match, we are allowed to do the multiplication. So let's go ahead and do that. So A times B is going to be a matrix. The first element, we're going to look at the first row times the first column, and we're going to add the terms together. So 2 times -2 is -4, plus 3 times 1 is 3. All right, next element. So now we go over to the next column. 2 times negative 2 is negative 4. 3 times 7 is 21. All right, we're out of columns. So now we go back to the first column and go down a row. And we repeat that process. So negative 1 times negative 2 is 2, plus 5 times 1 is 5. Next column, negative 1 times negative 2 is 2. 5 times 7 is 35. Last set, 9 times negative 2 is negative 18. Negative 3 times 1 is negative 3. Move this over. 9 times negative 2 is negative 18. Negative 3 times 7 is negative 21. And now we just have to simplify all of our elements. So we're going to have negative 4 plus 3 is negative 1. Negative 4 plus 21 is 17. 2 plus 5 is 7. 2 plus 35 is 37. Negative 18 minus 3 is negative 21. And then negative 18 minus 21 is negative 39. So this is the result of multiplying matrix A to matrix B. Now they want us to do matrix B times matrix A. So this, again, is a 2 by 2, and this is a 3 by 2. But we want B to be first. So if we take this and put it in front, we can see that the inner dimensions don't match for this multiplication. So B times A is undefined. There isn't a way for us to perform matrix multiplication in that order. So you just say it's undefined. There's not a process set up for us to do that. That's an illegal multiplication and you're not allowed to do it. All right, cool. So there's multiplication. All right, let's talk about determinants of a matrix. Again, don't ask me what a determinant is. It turns a matrix into one number and it does some stuff, right? Like that number is that number for some reasons, but don't trip too much about it. So let's talk about the two types of determinants you're going to see and what's required to even be allowed to find a determinant in the first place. To take a determinant of a matrix, it must be a square matrix. So a 2 by 2, a 3 by 3, a 4 by 4, etc. The ones we're going to look at are only the 2 by 2 and the 3 by 3. After the 3 by 3, taking determinants by hand becomes far too much work for it to be, how do I want to put this? Worth it? I don't know. You're going to have to take determinants of bigger ones someday when you get to college, as long as you don't decide that math is the worst thing that you've ever done and turn into a poli-sci major. But if you're going to college for a STEM field, then you're going to have to learn to take determinants of bigger ones. They'll probably show you, make you do one 4 by 4 by hand, and then say, okay, now do it with a computer for the rest of your life, which is how you would do it most of the time, right? So let's look at the determinants that I expect you to do by hand, and then we'll practice some. So for a 2 by 2 matrix, the determinant is very easy. You multiply the diagonal and then subtract the other diagonal. And then whatever number you get here, that's the value of your determinant. Okay. For the determinant of a 3 by 3, there's kind of two ways you can think about it. This formula here is the equation for the determinant of a 3 by 3. What this formula does is it goes through and does some mini determinants. So this first term is A times EK minus FH. So because we're using this first term, you kind of block off the first row and column and then use the determinant of what's left over. Then you just move that. So that's not going to work, is it? Shucks. So the next one would be B, and then you do your determinant of DK and FG. That's this. And then you do C with the determinant of EG and DH. So that's this here. So it's taking these numbers as coefficients, and then it's doing determinants of the bottom 6 elements. The other way that we can set this up that makes it a little easier to do by hand is you take the first 2 columns and repeat them and then do diagonals. So our 2 additional columns would be A, D, G, B, E, H, and then you do diagonals down to the right. So you multiply all these together, plus all of these multiplied together, plus all of these multiplied together. Then you do minus this diagonal multiplied together, minus this diagonal multiplied together, minus this diagonal multiplied together. If you distribute these in, this is what this turns into. So there's 2 different ways you can do it. If you're doing it this way, just remember that the coefficient in the middle changes signs. There's a minus sign there for some reasons, but don't worry about it too much. Just remember that you need a minus sign on that middle one. All right, let's go practice some determinants. So for our 2x2 determinant, you're going to have ones with both just numbers and then some with variables in there as well. I did just the variables one here because I think if you can do the variables, you can definitely do the numbers. So our determinant of A is equal to A times D. So 2 times 3x would be 6x minus this minus sign is from the equation right there. It's part of the equation. This isn't even from pluses and minuses on the elements yet. So minus b times c. So x times negative 2y is negative 2xy. So we have a double negative here. This minus is from there. This minus is from the equation of the determinant. So now we can just clean this up a little bit. Our determinant is 6x plus 2xy. Cool. All right. Now let's find the determinant of this. So I'm going to, which way do I want to do it? I personally prefer taking mini determinants, but that might just be me. You can do it either way. I'm going to do mini determinants because that's the way I like it. Maybe should use different variables here, but oh well. So our first one is going to be 2 times the determinant of this. 2 times 2 is 4 minus negative 3 times 3 is negative 9. Minus b times this. So we're ignoring this, So we're doing a determinant this way. 1 times 2 is 2 minus 3 times negative 2 is negative 6. Okay. Plus c, so negative 1, times, ignore those, do the determinant of what's not blocked off. 1 times negative 3 is negative 3, minus negative 2 times negative 2 is negative 4. Now we simplify. So minus a negative is plus, minus a negative is plus, minus a negative is plus. So 4 times 9 is 13, times 2 is 26. 2 plus 6 is 8, times negative 3 is negative 24. Negative 3 plus 4 is 1, times negative 1 is negative 1. So 26 minus 24 is 2, minus 1 is 1. So the determinant of that matrix is 1. Cool. So there we go. That's how we could do our determinants. I'm not going to do it the other way because you probably don't want to sit and watch me do determinants all day. Plus, we're going to do determinants over here anyway. All right, so we've talked about multiplying. We've talked about determinants of 2x2s and 3x3s. Now let's find the inverse of a 2x2 matrix. And what we mean by inverse is if I take the matrix A and multiply it to B, I'm going to get some new matrix C. What if I want to undo C and go back to B, though? So if I do the inverse of A times C, it should take me back to B. So there are inverses. Just like you can multiply by 2, the inverse of that is divide by 2. The inverse of multiply by 2 is also multiply by 1/2. So we're kind of, you might want to think of this as like the reciprocal matrix or something like that. It's the matrix that undoes itself. So our formula to find the inverse of A is going to be 1 over the determinant of A times this new matrix. So A is usually A, B, C, D. The way you get this new matrix is you trade A and D, you switch their spots, and then B and C get negatives put in front of them. All right, so let's go find the inverse of this matrix. So the first thing we're going to do is we're going to find the determinant of A. So the determinant of A is AD minus BC. So we're going to do AD is 6 minus B times C. So 3 times negative 2 is negative 6. Minus the negative is plus. So the determinant of A is 12. The inverse of A is 1 over the determinant times this matrix with that fancy transformation I showed you earlier. So we're going to trade these two numbers. We're going to swap them. So we're going to have 3 and 2. And then we're going to change the signs of these. So negative 3, 2. And then we can distribute this coefficient into all of these numbers. So the inverse of A is equal to 3 over 12. It's the same thing as 1 over 4. Negative 3 over 12 is just negative 1 over 4. 2 over 12 is 1 over 6. And 2 over 12 is still 1 over 6. So this is our inverse matrix. If I multiply this to something that A has been multiplied to, it'll go back to what it started as. All right, so there's our inverse of 2 by 2s. If you have to find the inverse of a 3 by 3, Google 3 by 3 matrix inverse calculator. I believe there are a couple of those that you have to do. I'm not even going to show you how to do them by hand. It's a pain in the butt. Use a calculator. All right. The last thing we have to talk about is finding the area of a triangle with matrices. This is really good. I don't know. I mean, I wouldn't teach it to you if it weren't useful for something, right? Like, actually, that's probably not true. Is that true? Do I teach you any unuseful math? Mr. Barton, everything you teach us is unuseful math. Maybe. Anyway, so if we have a triangle and it's somewhere on the coordinate axes like this, then if we can find its vertices, these 3 corners, and we know the ordered pair for them, is really easy for us to find the area of this. So if this ordered pair is x1, y1, this one is x2, y2, and this one is x3, y3. And which one's 1, 2, and 3 does not matter at all. Just pick them and be consistent, though. So if we have the 3 ordered pairs for the 3 vertices, we can put them into a matrix where we put ordered pair, fill in the last one with a 1. Ordered pair, 1. Ordered pair, 1. These vertical bars, instead of being brackets, they're just vertical bars. That means determinant. So you make this matrix, take the determinant of it, and then multiply that determinant by 1/2. That will be your area. And I think it's actually the absolute value of the determinant, because determinants can come out negative. I'd have to sit and think about that. I might have just lied to you, but there you go. There's your equation. So let's look at this. So Here we have a really goofy triangle. This would probably be kind of hard for us to figure out if we were just gonna, how do you say it? Try and find like a base and an area. If we were trying to use like 1/2 base times height, that's obviously not going to work on this because we don't know the base or the height of this goofy looking triangle. So what we need to do is use our matrix formula. So the area is equal to 1/2 times the determinant. Let's find our 3 ordered pairs really quickly. Actually, do I give them to you already? I do. They're right here. So we're going to fill in our matrix. So we have 1, 2, 1, 3, 3, 1, -5, 0, 1. So first we have to find the determinant of this. Then we're going to multiply that number by 1/2. And if the determinant's negative, we'll just make it positive. You can't have negative areas of triangles. So our determinant is going to be 1 times the determinant of this. So 3 times 1 is 3 minus 0. Okay, so that's 3. Minus 2 times 3 times 1 is 3. And then 1 times -5 is -5. Then our last one is going to be plus 1 times 3 times 0 is 0. Minus 3 times -15 is -15. So now we simplify this. This is 3. Turn that to plus. Turn that to plus. 3 plus 5 is 8. Times -2 is -16. And then 15 times 1 is 15. So -16 plus 15 is -1. Plus 3 is 2. This is our determinant. So our area is equal to 1/2 times 2. So our area is 1 unit. That's crazy. This whole triangle would fill up exactly one of these squares. That's crazy, isn't it? Cool. All right. So there you go. That's everything you need to know about matrices for the time being. They're fun. They're exciting. They're not too bad. They're kind of a lot of work, but it's kind of zen, isn't it? You sit and you just calculate determinants. You're just multiplying. I find it very meditative, maybe. You know what I mean? It's like aimlessly doodling. That's kind of how I feel about matrices. It's like sort of aimlessly just multiplying and subtracting. It's kind of fun. I enjoy them. All right. Have a wonderful rest of your day, folks. Thank you for watching this video. Don't forget to like and subscribe. And make sure you do your homework. All right, I'll see you guys next time.